Hey, Honors Algebra 2 students. I wanted to kind of go over an example that I saw when I was grading your guys' quizzes that I felt like a lot of people got incorrect or had some issues on. And so I figured I'd give you a quick video on how to kind of go through a graphing problem that involves a point of discontinuity. All right, so let's say we have this rational function, and this goes for any kind of rational function. So on your test, I am going to be asking you to kind of graph a couple functions by hand, kind of like what we did on the quiz. In addition, you're going to have a whole section on big ideas that is going to be like about, multiplying rational expressions, dividing, adding, solving, all that kind of good stuff. But for the graphing ones, what I would expect that you would do, and this is kind of the first rule of thumb for all of them, is to factor everything. So factor your numerator. So I would get x plus 3, x minus 2. Factor your denominator. So this is a binomial, so the only thing I could factor out there would be an x. Notice that there's a common factor between the numerator and the denominator. This is where the point of discontinuity occurs, okay? Anytime there's that common factor between the numerator and the denominator, that's your point of discontinuity. So what I want you to be able to do is, number one, find the point of discontinuity, because that's one of the things I kind of put everything on here so you could get a practice of finding everything, but that's one of the things you may be asked to find. And so the point of discontinuity occurs at the factor x minus 2. So take that factor, set it equal to 0, and solve. So I get x to equal 2. So what this means is there's going to be a hole in my graph when x is 2. So to figure out the y value, right, because it's obviously a point, right, it's called a point of discontinuity, you need to reduce this function, okay? So I'm left with, so my new function after I reduced it is this, x plus 3 over x. What I saw was that when you guys were doing like vertical asymptote, x-intercept, and behavior, all this other stuff, you were using the original function or this version of it. And I don't want you to do that. So you have to reduce your function. So factor it, reduce it, find that point of discontinuity, and then now everything is based off of this new reduced function. So this is what we're going to use to then finish our point of discontinuity as well as find all of the other information. All right, so let's do the point of discontinuity. We know our x value is 2. So all we're doing, this is like saying y equals, just plug in 2 for x. So I would get 2 plus 3 over 2. So I would get 2.5. So all that means is I'm going to have a hole in my graph. So when I graph this, sketch a graph, I'm just going to put a hole in my graph at that point. All right, now let's go ahead and look at our reduced function. And now let's find our vertical asymptote, our x-intercepts, and all that kind of good stuff. Do not use your original, because then you'll have like an x-intercept of 2 and you'll have a vertical asymptote of 2. And that doesn't exist, right? Because that's where that point of discontinuity occurred. So my vertical asymptote would be my denominator set equal to 0. Notice that I'm writing it as an equation. I am going to take off points if you do not use correct notation on this test. So asymptotes should be equation x equals or y equals. Intercepts should be points. So the x-intercept is when you set the numerator equal to 0, so I would get -3. So again, notice I wrote it as a point. End behavior asymptote, you could do polynomial division, so you could take x plus 3 divided by x, or you could just look at the properties. Remember we talked about the rule of if the degree of the numerator, which is 1, and the degree of the denominator, which is 1, if they're the same, then it's leading coefficient over leading coefficient. So leading coefficient here is 1, leading coefficient here is 1, 1 over 1 is 1. Again, your end behavior asymptote needs to be a line. It's always y equals. Just like your vertical asymptote is always a vertical line, so it's x equals. All right, let's talk about domain. So domain, I want you to make sure you have the correct notation. A few of you did not have this part correct, and I do want this in set notation. So this means all real numbers. And what you're going to exclude, so remember we talked about in a domain you're going to exclude all your vertical asymptotes, so in this case it's 0. But because you have a point of discontinuity, you have to exclude the x value of your point of discontinuity as well. So we're going to exclude 0 because it's a vertical asymptote, and then we're also going to exclude 2 because it's the x value of my point of discontinuity. So these are the two exceptions or areas of my graph, with the vertical asymptote and the point of discontinuity, where the function is undefined. For the range, let's go ahead and sketch the graph before we do the range. All right, so on this one, what I would do is let's go ahead and, again, we're graphing this one, right? We're graphing this function, not this original one, because we had to reduce out that point of discontinuity. So my vertical asymptote is 0, so I'm going to put a vertical line here. My end behavior asymptote is 1, so a horizontal line at 1, so roughly about here. I have an x-intercept of -3, so I'm going to put a dot here, or a point here. I'm going to ask that you find a couple points per branch. So I kind of already know that this branch is over here, right? It has to approach my asymptote. It has to kind of be in this section. So to get another point, I'm just going to draw a quick table here. So I already have -3, 0. I might do -2 because I want to know kind of like how steep that is. So if I plug -2 back into my reduced function, so that's this one, I would get -2 plus 3 over -2, which would be 1 over -2, which is -1/2. So again, I know that you can use your calculator on this. I really don't think you need to. I would actually kind of encourage you to not use a calculator just so that you can get in the practice of doing so. So -2, -1/2 would be about right here. That gives me my 2 points for this branch, so I'm going to go ahead and sketch it in there. I'm going to guess that the other branch is up here, right? Just based off of, all of the information that we've had before. So I'm going to go ahead and plot 2 points. I'm going to plot when x is 1 and when x is 2. So I'm going to add those 2 points to my table. So when x is 1, I get 1 plus 3, which is 4, 4 over 1, which is 4. So I'm going to go ahead and put a dot there. And then 2, when x is 2, I get 5 over 2, which is 2.5. So remember, that was our point of discontinuity. 2.5. So about right here. And I'm actually not going to put a point there. I'm going to put a circle there because if you remember, 2 and 2.5 was actually our point of discontinuity. So that's going to be, so we're going to have our graph is going to look like this. It's going to approach our asymptotes, and there's going to be a hole in the graph at that point of discontinuity. So this is all of the stuff. So we've got our graph. This is our function we graphed. We did all this information. The only other thing we need to do now here is find the range. So we start off the same way as we do the domain. It's all real numbers. We're going to exclude, whoops, I need to have y here. We're going to exclude. So based off of this graph, because there's one horizontal asymptote, one vertical asymptote, the only y value that's excluded here is that horizontal asymptote. So I'm going to exclude 1. But I also have to exclude the y value of my point of discontinuity. So notice that the x value was excluded in my range, my domain, I mean, and then my y value is excluded in my range. So that would be kind of the most, generally I'm not going to ask you to find all of this stuff, but I did see this kind of mistake here that a lot of people, named vertical asymptotes, they included this value here because you didn't reduce it, and then, sketching the graph and so forth. So this is an example of just kind of how to do this, this point of discontinuity graph. Again, very similar to what you're going to see on the test in terms of you're going to be asked to graph a couple functions. I want to encourage anyone who has questions. I'll be available before school for Blackhawk Hour on Monday and Tuesday before you guys take your tests. As Wednesday as well for those of you who take the test Wednesday. But I encourage you to kind of stop in and ask questions if you have any. And then if you can't, you can always try emailing me and I can do my best to kind of explain that way. All right, thanks for listening. Bye.